Hey guys and girls, welcome back to another beautiful video on this beautiful day on this beautiful channel. So what we're doing today is kind of a follow-up to the last example, but we'll be doing everything again since you don't have to watch these in order, right? What we're going to be doing is adding a copy constructor to the whole thing and an assignment operator. Okay, so you're going to be able to have two different arrays and then like copy them to each other and do whatever you want. And then we're going to make hopefully try to make a pop function where we remove something. So let's just get started without any delay. Let me see. Boom. All right. I just gotta check one thing. All right, we're good. Let's start with template. Type name T because we want a generic class. Let's call it array again. Let's call it a T array again. And then boom. Did I comment everything out? No, I gotta comment everything out in the last videos. There we go. T array. All right. Now private and then public. Now remember, we always have the same thing in private. Whoops. We have a int capacity, int number of elements, and then the actual array, T array, and then in private, and I found out a better way to do the expand function. I'll show you guys in a minute here. T array. This is going to be the kind of thing here. Size. Usually have 5 there. I like 5. I don't know why. It's a nice number. So usually keep it at default 5, and then we have the constructor and destructor can't even speak, completed, and we're gonna make a T array, which takes a const T array object reference to it, which is going to be the copy constructor, and then we're gonna make our operators appear this time. We're gonna make a T reference operator, boom, const int index. All right, then we're going to make a how was this one made? You know what, we'll just skip that for now. We'll go ahead and do void expand, and then we'll do before that we'll do void initialize, and then int from, then we'll do a void push const T reference object, and since we had push, expand, initialize, we need a const int reference size, which is a const, and this is going to return this number of elements. This is inline as well. Bam, there we go. We got everything. We'll try doing a pop as well. Void pop at index index. There we go. So at a given index, we'll try to remove something. If I don't remember how to do this, we'll see what I will do. We'll improvise. I bet I can do it. Let's see. So we have everything here, and let's just get to coding. So of course we'll start with the constructor. Boom, T array, T array, and then int size 5. You guys remember how to do this? You do the cap. This cap equals size. This number of elements, we start with 0 elements, valid elements, and this array equals a new T pointer array of the size, this capacity. All right, and that's about it for the constructor. I guess we need to initialize it. This initially initialize from 0. guys and girls, and we're good. Can't count how many times we've made these dynamic arrays, but this is the best way to practice pointers and just knowing how these things work. It's really good to know what a pointer is and such. And then we will do the destructor, which is empty, and then a for loop which goes to this number of elements in this array. So we're deleting what every pointer is pointing to. So every pointer in this array is pointing to data somewhere. We're deleting this data that is pointing to. So all the fingers of the hand are what they're pointing to is being deleted, and then we'll delete the actual hand with all its fingers here, this array. So the actual array is being deleted, and here everything the array is pointing to is being deleted. Bam, we're good. We're gonna make the copy constructor now, which you can just copy this, and so what's gonna happen is you make another object from another object. That is what a copy constructor is. So every time you create an array, if you create it with the use of another array, that's going to use the copy constructor. If you create the array by itself with a size, it's going to use the regular constructor. So it's good to have. It's good to have const t array object. So what do we need to do? Basically the same thing. The new object is going to have everything it needs to have. It has a new kind of, just new everything by itself, but it's going to use the data from the other object. So object.cap, and then since we're using the object of the same array, or the same type, the same type, we can call its private members directly by just accessing them. We don't have to care really. So object.number of elements, this capacity, and then obviously we want it to have its own members. So what's gonna happen is we're gonna go ahead and do this number of elements, because it has the same number of elements now. It's the same size, and we're gonna go out with this array at position I equals a new copy, new t copy from objects array at position I. Boom, dereferenced. Alright, so what this is doing is making a whole new set of variables, data for our new array, which is being copied over. That data is being copied over from the old array, or the other array basically. You can still use both arrays, it's just that they're the exact same copy, right? And we don't want this array to point to the other object's array. We want it to have its own set of data, although it's a copy. So it's going to have the new objects, which are the same as the other object. And then what we're going to do, I'm just thinking here, we need to make this operator. Alright, so we'll make that operator. We made this in the last video as well, but that's cool. We can do it again. T-array operator, boom, and what was it? It was a t-reference operator, and constant int index, boom. And here we did the error check. We said if the index is less than 0, or the index is greater or equal to this number of elements, we're gonna throw an exception, out of bounds, capital because we're cool. And then this array at that position, if nothing is wrong, because this is gonna get out of the function if something's wrong. If nothing's wrong, we're just gonna make a new t, and then, oh no, what am I doing? Return this array at position I, and you want to dereference this because it's an object we want to return, not the pointer. Boom, that's gonna be fine. So we have that going. Now Now. Let me just put all this stuff down here. So we'll get ahead and go ahead and do this. Initialize. Did I fix it? Nope. Okay, so let's start with initialize. That's the easy one. That is easy. All we have to do was the for loop, and we go to this cap, and then from. Oh yeah, we need this as well. So we go from the end of the valid kind of array to the void space and just initialize all that. So this array at position I equals null pointer. That's all you have to do. Boom. That's all you have to do, basically, and we'll be good. Now expand was the interesting one. Figured out a better way to do this. We'll go ahead and just do that. It was basically the same. It's just a little more efficient, so a little cleaner, rather. So this cap is doubled. Then we'll make a t pointer temp array, which is a new t pointer array of the size cap, the new capacity. Make a for loop. We'll go to this number of elements. We'll say temp array. Now this is the cleaner part, is equal to this array at the position I. So it's gonna straight up point to the object. It's not gonna copy anything. It's gonna point, because we're still gonna remove the old array once temp array is kind of holding on to its data, so we can remove the old one. So instead of making another for loop and deleting a bunch of stuff, we're just gonna delete the actual hand that is holding everything. Now I want to actually show you guys what is happening here. This array equals temp array. So it's pointing to that, and then we're just going to hit an initialize from this number of elements. So what is happening here? These are the different steps, right? So what if we do a little paint session here? All right. What if we just do this? So what is happening is we have our capacity. This is our old array. We want to make this grow bigger, right? We want to add like this much to it. We want to double it in size, basically, right? Expand it, because we reached the end of it. We can't add more elements, so we want to expand it. Now what happens is that to do this, we make this is our array. All right, so what we're doing here is we're making cap multiplied by 2. So cap, say that cap from the beginning was 5. Now we're making cap 10, and what that does is allow us to, in the next step, make a temporary array, which is double the size. It's double the size, and this is called temp array. All right. Now say that we have valid elements here, 1, 2, 3, 4, 5, all the way to the end. Now there are no like, what do you call it, null pointer or anything. Here we don't have null pointers. It's just random data. It's really like, you don't want to delete that because you're going to get a crash. So it's random data just in every space in here from the beginning. So what happens here is that we go through, in a for loop, we go through the old array. Here's the old array, here's the new array. What we're doing is each one of these arrays is actually pointing to something, right? It's pointing to something, which is data, which is some data in memory, right? That's what it is. These are pointers. These aren't pointing to anything. We still have these pointing to data here. 1, 2, 3, 4, 5. Okay, we still have these pointing to data. All we're doing in this for loop is we're straight up going from these 4 and just pointing them to these. All right, that's what we're doing. 5 pointers in here are pointing to something, so they have their data now. After the for loop is complete, they have their data. This is still like 5 random things in here. There's nothing you want to deal with. So that happened. Now this is the array, and this is the temp array. Now what we can do, since these are already holding on to the valuable data, we can delete the array. So what we're doing is we are completely just deleting this array pointer here, right? We are deleting this. This is gone. This pointer is now not pointing to anything. It used to point to an array of 5 pointers. It's not pointing to anything, and the data that was there, this data up here, straight up copy paste that. Straight up copy paste that data. Now they're not pointing to this. This is gone. Like, there are no pointers pointing to this except for the ones in the new array. Alright, so sorry for being tedious. You can fast forward if you want, but they're pointing to this data now. These 5 pointers in here. Alright, they're pointing to that data. We deleted the old array. Now all we're doing is, you know, actually that isn't good to do. Array is still there. Like, this is still a pointer. It's a valid pointer. It's just not pointing to anything anymore. What we do is, here's temp array. What we do is we just take this array pointer and we point it to whatever temporary is pointing to. So array is now pointing to temporary array, which in turn is pointing to all this data. And now initialize just goes through everything and makes these into null pointers, these 5 pointers in here. So we're good. Now this thing is the important part, because now array, our old array, is now pointing to the new array created here. Temp array, this variable here, is just a pointer, right? It's a pointer, and this is gonna be deleted at the end of this, but all the data that it created won't be. So it's good that we put our old pointer to use, pointing it to the new data. So that's what's happening. So at the end of the array, or the end of the function, temporary is going to be gone, but the data it created is still going to be there, being pointed to by array. So I hope you understood all the steps. Try to explain what the hell's going on, why we can do this instead of the other way. And basically, yeah, that's it. Like, I mean, it's not harder than that. And then just to finish off, let's make push and pop. Push and pop. So pushing it is gonna be easy. Whoops. Go ahead and do that, and then t array, and then there we go. If this number of elements is greater or equal to this cap, we're gonna expand, and then in the end we're just going to do this array at position this number of elements plus plus equals new t object, copy of that object, and there we go. We can push stuff into our thing. Now this is a little more difficult because we have to go to the index. If index is greater than, no, less than 0, or index is greater or equal to this number of elements. Oh yeah, whoops, gonna have to do this first. Make sure everything's correct. Okay, so this number of elements, we're doing the error checking. If it is, then throw out of bounds, else it's going to go to that index and it's going to delete that pointer. Now what we can do is this array at position I, so delete this array at position I, then we want to just move over everything. All the data should be moved over to that position. So all the pointers are going to be pointing to the pointer ahead of itself. So we're going to go to this number of elements. All the pointers. Okay, so -1, because what we want to do is we want to go. Let me illustrate this for myself as well. What if we have 5 elements and we want to delete this one? So this is going to be a null pointer. Now we want to go from this position. This pointer is going to point at this. This pointer is going to point at this. The data this is pointing to. So it's going to be like chick chick and we can delete the last element. Okay, so just going from index, so this array at index I equals to this array at index I plus 1. So they're going to point to everything ahead of itself, and then we're just going to delete this. No, we're not going to delete it. We're going to this r at number of elements minus minus equals null pointer. That should be a valid delete function. I'm not sure, but it should be. You know what? Let's try that out. Okay, let's see. What was it? T array int. Just call it array. R dot push. Let's see. Push 20. Let's push 20, and we'll make a for loop. Dot size. We'll just go through and print everything out. See out. Or at position I. Whoops, sorry about that. And line. So let's just see if everything works first of all. Nope. Oh, whoops, index. There you go, I always get that mixed up. Okay, so nothing crashed. Oh yeah, and guys and girls, you can add this to check for memory leaks, so you know what's going on. So, and then you'll see it in here as packets lost and stuff. Now, I didn't get any of that. That means I don't have any memory leaks. Easy to get memory leaks when you're playing around with pointers and stuff. But system pause. All right, boom. 20. Okay, good. No memory leaks, nothing. Let's push 7 something onto there. Let's see if that works with expand. Yep, expand worked without any memory leaks. Okay, so now if I want to pop 40, let's just add some numbers in here again. Just like that. See, so they're all different. Yep, we got all of them in there. Now if I want to pop something, let's say array dot pop something at, what I want to do, maybe 3. So 3 would be 0, 1, 2, 3. So 50 should be gone if we print this out again. We shouldn't have to do that. So I should be able to remove 50 by doing this. Nope. Ugh. Sorry about that. Index. Okay, so 50 was removed, and I didn't get any errors. Alright? Cool. Cool. Wow. I did that on the first try. I didn't think I'd be able to do that. Low self-esteem. Hello. But still. That was great. Okay, so 0 worked as well. 220 was removed. Let's do 1. So 1 is 260. 260 is removed. So what would this be? 0, 1, 2, 3, 4, 5, 6. 6. The last element. This is the one that is crazy. Okay, so it was removed without any problems. It was removed. We're good, guys and girls. We're good. Hell yeah. Great job. Great job to you. Great job to me. Hell yes. This is a more advanced version of the template array. Pointer template array. So yeah, thanks for watching, guys and girls. Hell yeah, that was fun. Take care, and I hope you learned something. Keep watching my videos, learning stuff, or any videos for that matter. Just keep programming. Stay safe, and we'll talk and program in the next video. Alright? Peace out.